everyone, welcome back to Tech is Strong with Shobhit. I hope you are doing great in tech and life. Just remember one thing, when tough time came, don't say why me, say try me. Let's come to topic which is typecasting in C. C gives you the power to reinterpret memory any way you want. That power can make you a system engineer or crash your program silently. Today we will break down implicit versus explicit casting, when casting is safe, and why pointer casting is where real bugs lives. Typecasting does not change memory, it only changes how you interpret it. Memory is just a raw byte. Types are contract on top of those bytes. You can see the diagram. If I'm saying that particular raw bytes is integer, it can be read as integer. Okay. If it is 65, then it will be a 65. If I'm saying it's a character, then it will be read as interpret as character. Means 65 become A in S type. So it's like that. And once you understand this, every casting bug starts to make sense here. Implicit casting. Let's see the left side of the diagram. I'm saying int a equals to 10 and float b equals to a. This is safe because here value is widened. No data is lost because I am casting integer into float. If you see in the right side of the diagram, int a equals to 300 and character c equals to a. So here, integer size is 4 bytes, and you are casting that into a character, which is 1 byte. So obviously, that data will be lost. So you have to remember one rule: widening is usually safe, and narrowing is dangerous. Explicit casting tells the compiler, "Trust me, I know what I am doing." If you see left side of the slide, float f equals to 3.7, int I equals to, I'm casting f into integer. This truncation is intentional and valid. But once you cast explicitly, compiler warning disappear. Undefined behavior become possible. C will not protect you anymore. Pointer casting. This is where system break. If you see left side of the slide, where I'm converting integer pointer into character pointer. What does this mean? It does not convert a data. It is just, giving the reinterpretation of raw bytes. So previously, if I am doing x plus one, address of x plus one, what does this means is if x is at 100 location, then it will move to 104. But if I'm doing p plus one, then what it will do is it will move to 101 because character is of 1 byte. Yeah. So now yeah, this is the one example. If you see in the right side, I'm showing an example where character buffer 5, and then I am converting this character into integer. But what I did is I did buffer plus one. Okay, so what this means is it will misalign the memory, and this P is pointing to the misaligned memory. So I already covered in the previous episode what is this alignment, misalignment, and everything. So you can watch out that for more understanding. And due to that, some program crashes, and yeah, on some CPUs, I can say. So you have to remember one thing that pointer casting plus misalignment will give undefined behavior. Pointer casting is used legitimately in memory mapped I/O, hardware registers, firmwares, and drivers. This works because hardware guarantees the memory layout. Without that guarantee, don't do it. Actually, we have a sheet for particular register is at the particular address, and it is of that type. So everything is written. That's why we can easily map to that sheet and do the conversion easily. If you are working as an embedded engineer, these golden rules you must remember. And if you're an application or college student, also you need to remember that for the interview purpose. So there are few rules follows. Like first one is casting does not change memory. I already told you that just it is just a reinterpretation we are doing. Nothing change in terms of memory. Next is widening is much safer than narrowing. Third is explicit cast remove safety. Fourth is pointer cast are the most dangerous. We saw that we misalign the memory and then casting, then it crashes the system for sure. And fifth one, which is last one, is alignment always matters. Typecasting is not about syntax, it is a trust contract between you and the machine. If this save you from the future bug, like, comment, subscribe, and stay tech strong. Thank you so much for watching this episode.